In this video, we're going to look at what forecasting model should be used when we have a time series pattern that exhibits both a seasonal pattern and a linear trend. So not only a seasonal pattern, but also an incline or a decline in our sales. Once again, in these 2.6 videos, I'm not going to focus in on how we establish the time series pattern itself. So please, if you're looking for further information on how I established what the time series pattern was here, consult back to the 2.3 videos that do focus on how we do establish the time series pattern itself. So here, after establishing that we do have not only an upward trend in the data, but also along with that upward trend, we can see there is definitely a clear separation in quarterly sales. So our data is exhibiting both a linear trend and seasonality. So the forecasting method we need to use needs to encompass both of those aspects. Again, as soon as we have seasonality, we'll be dealing with multiple regression, but our multiple regression now not only has to encompass those dummy variables that we established in the last video, the seasonal dummy variables, but it also has to encompass the simple regression stuff we did back when we had merely a linear trend. So once again, our forecasting method will be based on getting our regression equation. Because we have seasonality, we need to create dummy variables, and always one less dummy variable than we have seasons. So here, 4 seasons or 4 quarters. So inserting 3 extra columns. Again, our dummy variable for each quarter, we want only values of 1s or 0s. The video prior to this went in a little more detail about how we establish this, so I'll glance over it a little more quickly here. Using our if statement, if this row is dealing with quarter 1 in this column, so if that first row equals 1, I want there to be a 1 value. If it's not 1, I want it to be a 0 value. Similarly, in the Q2 column, if I'm told in this column that it is quarter 2 now, I want it to be a 1, otherwise a 0. And finally, for Q3, if I'm dealing with Q3, 1 if not 0. Copying, pasting that down to all subsequent periods. So once again, we are asked here to forecast for all of the seasons in the following years. So our 4 quarters of year 5. Inserting a little extra space here. So in year 5, we want to deal with quarters 1, 2, 3, and 4. So again, our forecast is based off of the regression analysis. So data analysis, regression, Y variable is always what we're trying to predict, sales. However, now our independent variables are not only our 3 dummy variables, the quarterly sales, but here we also have that increasing trend. So now we not only have to encompass these dummy variables, we also want the prediction based on what happens in the upward or downward trend year after year. So when we have a combination of seasonality and a linear trend, we need to talk about all our dummy variables as well as the periods that we did with the simple regression when we only had a linear trend. So if we're only dealing with seasonality and a horizontal pattern, we only use our seasonal dummy variables, but here, with a combination of the seasonality and the upward trend, we'll use our 3 dummy variables as well as our variable of our time period. An appropriate output range, hit OK, and once again from our regression output, we should be able to establish our regression equation. So here we get a regression equation that y hat is approximately equal to 6.069 minus 1.363 x1 minus 2.033 x2 minus 0.304 x3 plus 0.146 x4. So here I've simply rounded those values to fit them into the equation. However, our predictive model should always be based on the full unrounded values. So establishing our predictions for year 5, we not only have to take into account our dummy variables, but again, our regression equation also took into account the period that we were dealing with. So we will also have to take that into account with our predictive model. So copying and pasting that down, we're now dealing with periods 17, 18, 19, and 20. As always, anything referenced back from our regression output needs to be absolute reference. We'll be using these values for the predictions for each of the following periods. So absolute reference, our coefficient of our y-intercept. Absolute reference, the coefficient of our first independent variable multiplied by the appropriate variable of that period. And continuing that pattern along for each of the independent variables, absolute reference out of the regression output, and a non-absolute reference for anything within the data that we're trying to predict for. We should get the following predictions for each of the quarters of year 5 and quarter 1. We expect to sell 7,180 televisions. Quarter 2, 6,660. Quarter 3, 8,530. And in quarter 4, 8,980.